All right, so worksheet 12, exponential and log equations. If you missed yesterday, I know there were several of you who were gone. Hang on, what's happening here? There we go. All right, if you missed yesterday, we went over worksheet, I want to say 9B, that had 4 different strategies for solving exponential equations or log equations, okay? You definitely want to take those notes on 9B because primarily you're going to see those strategies used over and over again, pretty much, not a lot on strategy 1. I would say 2, 3, and 4 for sure, okay? We will touch on those right now, but those are good. That's a good notes sheet to have to refer to when you're stuck on which kind of question it is. All right, so one of the properties we talked about yesterday was the one-to-one property. Now there is one for logs and one's for exponents. This is a typo up here. It is supposed to say, and maybe I fixed it, I don't know, but it's supposed to say b to the x equals b to the y, then x has to equal y, right? If you have the same base, then the exponents have to be equal as long as it's written in that format. The same is true for logs. If you have log base b of a bunch of garbage in here, and it's equal to log with the same base of a bunch of different garbage over here, then the things in the parentheses have to be equal. This making sense, guys? Okay, now, all right, we're just gonna move on, and we talked about that yesterday. Let's do some examples, okay. This is the kind of problem where you can adjust the base. We got to these at the very end of class yesterday. How could I rewrite these so they had the same base? I could make them both powers of 2, but I could also just make 16 into a power of 4, and then they'd have the same base. Everybody okay? So I have 4 to the x minus 1. This could become a 4 squared, and then there would still be that x out there. Is everybody okay that just changing the 16 to a 4 squared? Now, what is the rule about numbers in this position? So like, if we had a 4 to the 3rd to the 5th power, it would really be a 4 to the 15. Everybody remember that rule? Okay. So here we're going to have a 4 to the x minus 1 equals 4 to the, this is really just a 2x. Then that one-to-one property simply says, therefore the exponents are equal because the bases were equal. If we solve, everybody good? So if you put that back in, you don't have to do this. I just want to show you that it works. 4 to the negative 1 minus 1 equals 16 to the negative 1. Well, 4 to the negative 2 equals 16 to the negative 1. I'm hoping you're getting the idea with the negative exponents that it belongs in the denominator. So this is a 1 over 4 squared. This is a 1 over 16 to the first. Is that true? Okay, just trying to review those properties of exponents. All right, this one, on the other hand, never seen this before in your life, right? We did not do this yesterday. All right. This is a confusing concept for many, but remember when we did fancy factoring with stuff like this? Does that work? It would factor x squared minus 5 and x squared minus 1 to get a negative 6 in the middle. I was trying to make one up on the fly there. Does that work? Okay, so this was very uncomfortable, yes, but we eventually, I hope, kind of got that down. Kaylee and Kaylee, these are for the two of you. Okay, this is somewhat similar. It's just a little bit harder to understand for many. This is an e to the x squared. Everybody get that a 2x right there could be written that way. And then this is a minus 3e to the x plus 2 equals 0. For many students, this is easier to understand if we just say, do what we call a u substitution. I'm going to let u equal e to the x. So then this becomes a u squared minus 3u plus 2, which would factor u and u. Factors a 2 or 2 and 1. To get a negative 3, I need a negative and a negative. So then this would solve u equals 2 and u equals 1. That part seem okay? Okay. The issue is that u was really e to the x. So unfortunately, we have a whole nother step when we get here to the end. Okay, let's back up for a second. How do we solve when the x is in the exponent? If we have 3 to the x equals 7, does anybody remember the strategy from yesterday? Whenever x is in the exponent, you have to take the log of both sides. Does that sound familiar? That's one that I stressed over and over, like I said it 4 times in a row. Whenever the unknown is in the exponent, you have to take the log of both sides. So if I did here, the log of 3 to the x equals the log of 7, you would move the x out front. Remember that property of logs. And then you would just divide by the log of 3 on both sides. So you would have had x equals the log of 7 divided by the log of 3, and you'd get some ugly decimal. Okay, we did those yesterday. What do I want to use over here, though? My x is in the exponent, okay? But I want to use something that'll help with the fact that there's an e also in the problem. So when I go to take the log of both sides here, we have 2 problems, I'm going to do the natural log. So the natural log of e to the x equals the natural log of 2. Over here, the natural log of e to the x equals the natural log of 1. The x can move up front. What is the natural log of e? Guys, you got to know that. The natural log of e is just 1. Oh, you're doing some pictures? Okay. Yearbook pictures, just trying to, pictures of math team and math students in action. Okay, guys? So look natural. All right. ln of e is just 1. So we actually found the answer, okay? X equals the natural log of 2. That's an exact answer. Can anybody give me an approximate answer? Type natural log of 2 on your calculator. What decimal do you get? .693. Anybody agreeing, disagreeing? Okay. So this had an exact answer of the natural log of 2 and an estimate of 0.639. All right, this one actually we can move the x out front. X ln of e equals natural log of 1. What is the natural log of e? 1. This is gone. So it says natural log of 1. Anybody think about what that means? E to what power is 1? What power makes everything into a 1? 0. Yes. So you could type this in your calculator. I'm not taking your calculator away. So if you typed ln of 1, you would just get 0. So a 0 would work to make this equation true, or around 0.639 would work to make this equation true. Now, there was so many side trips on that question. I think you all are totally confused. Let me go back over what I did. We said e to the 2x minus 3 e to the x plus 2. We made this a u squared and this a u. Factored and solved. Then we went back and said, but the u is really an e to the x. And unfortunately, we still had to solve for x by taking the log of both sides. Okay. Is there another one on here we could do of that kind before we do anything different? Okay, how about number 4? Can you find number 4? Okay. Number 4, this is like a 2 e to the x squared plus a 12 e to the x minus 54 equals 0. Anybody see something we could do right away? Okay, we can substitute first. So we're going to say e to the x equals u. I don't know why they call them u substitution problems, even back when I was in school. But you could really use any variable, but they call them u substitution. 2u squared plus 12u minus 54 equals 0. What I was meaning when I said something we could do right away, yeah, we could take a 2 out of all this. We'd have u squared plus 6u minus 27. Now, does 2 equal 0? Now, this is not going to be a solution. We really could just throw that out, divide everything. But this will factor u and u, factors of 27 that make 6, 9 and 3. To get a positive 6, we need a plus 9 and a minus 3, so that we would end up with a 9u minus 3u would be the 6u in the middle. All right, now we can finish this if you want. We can say u is therefore negative 9 or u is 3. Unfortunately, finish was kind of a misnomer because we're not finished. What is u? So we have e to the x equals negative 9, or e to the x equals 3. Now, whenever x is in the exponent, what do you have to do? Log of both sides. We're going to use natural log because it is an e question. Anybody see a problem here? Can you take the log of a negative number? No. So what do we get to do with all this? Just garbage, doesn't work, can't do it. I'll write a note here, not possible to take the log of a negative number, so we're done with that side. Okay, over here, we move the x out front. ln of e is just 1. So this is just x equals, this is just a 1, natural log of 3. So there's an exact answer. If you type that in, anybody give me the decimal? 1.099. Sorry. They suggest you also could have graphed this. Okay, would have been way easier, right? If you graph something like this, and then you see where it has a 0, it would give us the decimal, but it would not give us the exact answer. I haven't written the quiz for this yet. In years past, this question would ask for both the exact and the approximate answer, okay? So you do have to be able to factor it. We'll see, I'll decide by the time we get to the review. Okay, let me go back up here. Examples 1 and 2 are examples of when we can get a common base. Can I change a 3 into a 9 or a 9 into a 3 or both of them into a power of something? I can make 9 become what? 3 to the second? And then it is an x out here. We just changed the 9, and it is going to become a 2x. Whoops, this one had a 3x minus 4 up there. All right, now that they have the same base, this has to equal this. And there is multiplication over here, so we could just rewrite it as 2x equals 3x minus 4. Solve. I got positive 4. Anybody else? Okay. It says round to the nearest hundredth. We didn't need to round on that one. Okay, number 2. I cannot make an 8 into a power of 4. Is that true? I could make both of these, though, into a power of 2. Now, we could make them into powers of 1/2, or we could make these into powers of 2 that are negative. Anybody have a preference? Maybe I'll just leave it a half. This is a 1/2 squared, yes? 1/2 times 1/2 would be 1/4. And then there was already up here a 2x minus 1. Those are going to get multiplied. Just like we did over here. We did 2 times x. We're going to do 2 times what was already up there. All right, I do not have room to write this. Let me see if I can move all this disaster. Okay, this one, what is 1/8 as a power of 1/2? 1/2 times 1/2 would be 1/4. Another 1/2 would make it 1/8, right? 2 to the third is 8. That's where we're really going here. And we could rewrite these as powers of 2, but then we'd have to switch them to negatives to make them come from the denominator to the top. So this would be a negative. I'm sorry, this would be a 3, not a negative. And then we had an 11 minus x up there. Okay, now we have the same base. So what are we going to do to the exponents? Okay, can you guys solve this real quick? Put your phone away, Antoine, please. Be doing these. This is an equation you should be able to solve, even if you're stuck with how we got there. I got 5. Did anybody else get 5, or did I do something wrong? Yes, we're good? Okay. One more. What can I make these both powers of? 2. Now, I need to clarify something. Even back here, whenever x is in the exponent, you're allowed to take the log of both sides. I've said that, okay? That's how we solve these. But can you see how messy this would get if you took the log of both sides? So if they can be rewritten as a common base, that's the way we want to go, especially when there's x's in all over the place, okay? This is a 2 squared. Woo! Don't have a pen, sorry. This is a 2 squared to the 3x minus 2. But does anybody know what power that is that would put it into a 1/2? A 1/2 is really 2 to the negative 1. It was moved to the denominator. I'm feeling like I need another year. Because of COVID, I feel like we are weaker on our exponent rules than other years. We probably should have spent some extra time on that at the beginning. A lot of people who are confused right now about fractional and negative exponents. All right, now we can put these equal to each other. This is going to be a multiplication, and this is going to be a multiplication. So we have 2 times the quantity, 3x minus 2. You have to remember to distribute. And then over here, we just have a negative 1 times a 2x. So some of you should already be done solving that probably while I was chitty-chatting. Oh, be a little bit careful. Is this a fraction? Yeah, got to be careful. We're dividing by the right thing here, but I got 1/2 as well. Anybody stuck? All right. Now, what's different about 5 and 6 than the ones we were just doing? First of all, 9 and 12, can I make those a power of the same thing? 12 isn't a power of anything. And there's only an x in one place. That's the part that makes them different. Okay, when you have an x in one place in the exponent, that's when we have to do that strategy 2. I don't know which strategy it was, but it's the one where we have a single power of x somewhere, and so it said log both sides. I don't know which one it was. It doesn't matter which one it was. All right, so we're going to take the log of both sides, and it doesn't matter what kind of log. This one has a base 9, so it's not going to help to do ln or log, but you could do ln anytime. You can do ln every time if you want. Okay? It's shorter to write. So maybe I'll do ln. You can do log. It doesn't matter as long as you do the same kind to both sides. Okay, what happens next? Move that out front. So we have a 2 times an x times a log of 9 equals a log of 12. To get the x by itself, we just need to do a bunch of dividing, right? I always divide, I don't know why, other than later it might make more sense. I always do it in 2 steps. If you try to divide both things at once, you need parentheses, and I always worry students are going to forget the parentheses. So log of 12 divided by log of 9. Again, either base would work. You'll get the same answer. Natural log of 12 divided by the natural log of 9. And that's 2x, so we still need to divide that by 2. So 1.31, or after we divided by 2, 0.565. Did someone else get that? Do you guys know that this 4, if I'm routed into 3 places, I don't do the 6 becomes a 5 and the 5 becomes a 6, right? We just look at the number past the 5 there. Was it 565? Okay, so after we typed this in, we got some crazy decimal, and then we divided by 2. All right, help me quick through this one. Audience participation? Yes, remember we got to use our Algebra 1 brain first. Does that come out? You know what? This is where Hofbauer is lazy. I'm going to have to type my calculator in just a second anyway. I'm just going to leave that mess. 9.3 over 2.4. It's going to help us later to not have to round a bunch of times. Then what are we going to do to both sides because of the e? Take the ln of both sides. And then the x minus 6 is going to move out in front. And the natural log of e is what? Yep. So this is really times the natural log of e, but that's just 1. I think it's time to type, yes? We're going to type this in our calculator and get some crazy decimal. And then what are we going to do to finish? Just add the 6 over there. All right, natural log of 9.3 divided. This time it wasn't 2 separate logs, okay? We're clear on that. What was it divided by? I forgot, guys. Thank you. And then I added 6 or subtracted 6? Thanks. 7.355. And if you rounded differently, meaning that you rounded earlier in the problem somewhere, I'm going to be very generous, okay? And what they like you to do in Delta, did somebody do the homework last night? Does it usually say hundreds, thousands? Hundreds most of the time? Okay, so what I would do, if you're doing your work, do it to 3 decimals, because then when you round your answer to 2 for Delta Math, I think you'll be okay. Does that make sense? The problem will be if you round to 2 all the way along, you might be off by 1/10 or 100th or something at the end. All right. Okay. One where I can't write 6 as a power of 3, right? So I'm going to have to do log of both sides. It's going to get messy. So we're going to have the log of 3. Can I move the 2x out at the front at the same time, guys? And over here, I'm going to move an x minus 1 out there times a log of 6. I don't know why I randomly switched back to log, but I did. Okay? There is no nice way to do this, because we're going to have messy decimals all over the place. You want to just change it all to decimals and work with it? Or you want to divide something off first? Anybody have a preference? How about if we divide the log of 6 to both sides first? I'm just trying to not have ugly decimals on both sides. How's that sound? Okay, so all of this is an x times something, and over here we have an x minus 1 left. Can we do 2 times the log of 3 divided by the log of 6 and see what we get? 2 times the log of 3 divided by the log of 6. So 2 times the log of 3, close parenthesis, divided by the log of 6. 1.226, did someone get that? Okay, now what? So this is really just a 1.226x equals x minus 1. Subtract 1x from each side. Leaves a 0.226x equals negative 1. You could have done this algebraically 100 different ways. So negative 1 divided by 0.226. Negative 4.42 if we round to the hundredths at the very end, like Delta Math would ask you to. That was gross. Can you have a negative in the exponent? Remember, this started as an exponent. Yes. Can't take the log of a negative, but exponent can be anything. All right, can you guys do 18 just so I feel like you have a little confidence? This is an easy one. What are you going to do to both sides? Natural log. Move that out front. Ln of e is just 1. So it's just natural log of 23 divided by 19. This side doesn't have a log anymore. Jay, did you get a decimal? 0.15? 175? Is that what you said? 17. Yes? Okay, sorry guys. It's the mask thing and Hofbauer's old lady ears. All right. This is we already talked about this, yes? If they're the same log, like if we had, it says here log base b of x equals log base b of y if and only if x equals y. We already discussed that at the beginning of the lesson, that the same property works here. And then they proceed to have one that only has a log in one place. This is not that kind of question at all. Okay, Algebra 1 brain first. I hate this, but there's implied parentheses here. So I have 2 somethings minus 1. What should I do first? Add 1. 2 of those equals 12. Then what I should do? Divide by 2. That disgustingness equals 6. Okay. We need to come to an understanding. I would prefer that we rewrote this as 5 to the 6th power equals 4x. But last year, your teachers probably did some magic like this. called exponentiating. And they said a log base 5 and a base of 5 undo each other. So you end up with 4x equals 5 to the 6th. It's the same thing I would do, but I would say this blue sentence here meant 5 to the 6th equals 4x. Do you prefer to see the big fives? No? Okay. I just, if that's the way you learned it last year and you want to do it that way, I'm okay with it. I'm going to back up here. To me, this means 5 to some power equals 4x, and the some power was the 6. Okay? So then you just type in your calculator. What is 5 to the 6th? And divide by 4. Was this one already done for you, maybe? Did we get the right answer? Okay, then I'm just going to keep going. All right. Example 2. Oh. If this just said log equals log, we'd be golden, but it doesn't. This is a weird example. I think our best bet is to add this log over to this side so that all the logs are on one side. Log base 2 of x minus 6 plus log base 2 of 2x equals 5. Okay, we did these yesterday. When there's two logs on one side and none on the other, we need to combine those two. That's why we had to learn those stupid properties. Plus means multiply. So this becomes log base 2 of x minus 6 times 2x. I combined this mess and this to change the plus to one single log. Okay? Now, that means the log of all this is 2 to the 5th power, yes? You understand the base to the power. So, I'm going to write it in a different order. Okay? Now, distributing this, 2x squared minus 12x, I'm going to subtract, this is 32, subtract it over to the other side at the same time because anytime we have an x squared, we have to make it equal to 0. I take out a 2, that's an x squared minus 6x minus 16, factors of 16 that make 6, guys. Factors of 16 that make 6. 8 times 2, does that work? So, can 2 equal 0? No, but this would make x 8, and this would make x negative 2. Now, if I go back to the beginning, can I put a negative 2 in here? Negative 2 minus 6, would that be okay to take a log of negative 8? No. What was so I got to throw that negative one away. The other, no. Yes, that's the one I'm throwing away. Okay, sorry. Can I put an 8 in here? By the way, I could not put a positive 2 in here either because 2 minus 6 would still be negative, right? So you got to be careful. But 8 works. So it has one solution. Is that shown on your sheet? Was that one done for you? I don't know. All right. Oh, finally, an easy one. What do we do here? Yeah, they're equal, so we just have 3x equals 12x equals 4. Whew, it was a fun moment. Okay, we can do something very similar on this one. If we combine these two first, what does a plus between two logs become? So that is a 2 times an x. If I could only write what I said. Log base 12 of 2 times x. And then we didn't mess with the other side. Okay. Now they're the same thing, log base 12. So therefore, 2x equals x plus 7. Subtract an x, and we just get x equals 7, yes? Yeah. They're not like this on the homework in Delta Math either. Did someone actually get through the homework on Delta Math? There were some nasty ones where you had to do like factoring and junk. Okay. Whew, I don't think I want to do this one. I think these would be really big numbers. We don't have that much time. I don't think there's any with delta math where you start with 319. It's not that bad when you distribute here. You're going to get a 320 x squared. So you subtract it over and it's an x squared. I vote we just keep going. Let's try this one. What does plus mean? So this is an x times an x plus 16. On the other side, he also had a plus, so that means 8 times x plus 6. Now what? Since we have 1 log equal to 1 log, we can just get rid of the logs. Can I distribute as I go, guys? X squared plus 16x. And over here, when I get rid of the log and distribute, I'd have an 8x plus 48. What do I do next? Yeah, I got to get it equal to 0, so I'm going to subtract 8x's, which will give me 8 left over there, and then I subtract the 48. Factors of 48 that differ by 8. 12 and 4, good call. Plus 12 and minus 4. So we get x equals negative 12 or x equals 4. Okay, got to look back at the beginning. I don't think there's any way to make a negative work, right? Because right here, negative log of negative 12 wouldn't work. Once in a while, a negative answer is correct. For example, if it had said, 15 minus x, then putting in a negative answer would make it a plus. So, all right, this is an application. If the initial is the initial amount, so we had initially 50, and they gave us this lovely equation, and we're trying to get it down to 10. I'm going to do a lot more applications on Monday, but what do we do first? Algebra 1 brain. Divide by 50. E to the negative 0.00043t equals, I'm going to leave it 10 over 50, because what do we do next? X is in the exponent, so we need to take the natural log of both sides and move that exponent out front. And I dropped off the ln of e because that's 1. Everybody okay? Okay, so type that disaster in where you're going to just divide at the end, right? So t equals, somebody type in. Cheyenne, did you get it? No? What'd you get, Elo? Or star, sorry. Did you close your parentheses? ln of 10 over 50. It's going to be a big number, I think. 0.000, is that what it was? 0.00043? 3742 or 3743 if we rounded. Years. Okay. This was, by the way, I didn't ever read the question out loud, but how long will it take this to decay down to this model? Long time, radioactive decay. All right. So the assignment, I swear I put a slide together with this. Darn it. All right, I'm going to just pull it off the Google Classroom. It's a worksheet in your packet. It's worksheet 13, these 5 problems. Let me put it up on the screen. It's in the lesson plan if you need to, but here it is. Nice. Whoa, I thought nice and big. If you want to take a picture, show your work. Their homework check?
Yeah.